Hello everyone, finally the last bit of shifting vertically for our graphs. I've already made two videos. The one was this shifting of the sine one, how to understand what's happening, then the cos one, and basically I emphasized that when there is a plussing or minusing of a unit, it's shifting the whole graph either up or down. Okay, if it's plussing, it's shifting up. If it's minusing, it's shifting down. And now we're going to have a look at the tan graph. It is quite similar. There are just a few things to keep in mind. Okay, so let's jump right in. So over here, guys, the y equals tan x, that is the graph that I've drawn in black. And then the graph that I've drawn in red, the difference is there's been an addition of 1, so plussing 1. So again, the graph simply just shifts up a unit. So whichever intervals you had previously, you just shift it and put it in your calculator. So instead of it being 0, it's going to be 1. At 45 being 1, it's going to be 2. And etc. And you literally just do the same for every point. I think you can see what I have done here. So instead of at 360 the original graph being 0, it will have a plus 1. Instead of minus 1, it will be 0, etc. So that is how you draw it. But I do want to emphasize that you still have your asymptotes. So the graphs will still not touch at these specific asymptotes. Okay, and then what you'll end up seeing is that the answers for the domain, range, period, and amplitude are actually the exact same for the original as well as the shifted graph. Okay, I'm going to explain why. So if you think about it, for domain, it's asking where do the x values exist? Well, if you look at both graphs, they still exist all the way from negative 360 and it goes all the way through all the way to 360. However, it does apply for both graphs that they never touch what is the yellow dotted lines called? These are the asymptotes. So at negative 270 degrees, the graph never touches. At negative 90, it never touches, etc. So that is how I wrote it out here. I'm going to show you. So what you write over here is you just say, okay, so x does exist and belongs to from and including negative 360 all the way to 360, and then you write a comma here, same thing here. You are going to say, but x does not equal, that's what the line through the equal sign means, it's never going to equal exactly on 270, negative 270, or negative 90, or 90, or 270. So you write that for both, because it will never, ever exist and touch that specific degree. Okay, I hope that makes sense. Then again with the range, you can literally see for yourself that, oh, my computer is lagging. I'm so sorry, guys. You'll see that the range will actually stay the same because it still does continue to go all the way up and all the way to the bottom, no matter if it's your red graph or the black graph. So that's how you write it. Remember, when we are saying from a negative infinity, you write a round bracket because you can never touch infinity. So that's why it's the round bracket and not the square bracket. Okay. Right, and then period, remember I explained in grade 10, for tan graphs, your periods, they're always 180. If you want to understand what I said about a period and explain this in detail, I did make a video in this playlist, so just look for it. I think it's the third or fourth video where I do explain what they mean. I'll just explain it again. Period basically means how often or how long does it take for a graph to repeat itself. So yeah, and then with regards to the amplitude, again, amplitude is not applicable for both because it just continues to go upwards, so it doesn't really exist, if I can put it that way. So that one was pretty simple, guys, and then please look out for my next couple videos. We are going to go into how to sketch difficult graphs, which is really easy. Whenever you sketch, you just plug it in the calculator, and then also how to manage graphs where the amplitude is different. Okay, so yeah, stay tuned for that.